All right, so this sort of comparison has been going on for a while, and it's it's kind of a silly comparison um, because it's not like you win anything if one's better than the quote unquote better, stronger, deadlier, whatever than the other. Um, if COVID-19 was just another flu, then that still would be great. The flu kills a significant number of people. And we've already just talked about the limited number of beds in hospitals that are available at any given time. So that by itself isn't great. Now, we know from previous lectures that it's not like the flu. The flu has an R naught of about 1.3, and COVID-19 is about 2.3, much catchier. We're going to review a couple of these numbers because I've seen some of this conversation still happening in the media, and I think it's probably worth revisiting. So, again, being mindful of where we look for our information. So, I've got here the CDC site on the recent flu season. So, preliminary burden estimates. And the CDC decides at some point to stop tracking these things, and it gives us some estimates. Now, a lot of people probably had the flu, right? 39 to 56 million people. Somewhere around 18 to 26 million medical visits, 410,000 to 740,000 hospitalizations, and 24 to 62,000 flu deaths. And one thing you might ask is, why the range? 24 to 62,000? The difference between those two numbers would be all the fatalities due to car accidents in a year. Are they just not sure? This is one of the great things about going to the source. I recognize that cdc.gov is not high on anyone's reading list, but when you're trying to figure something out, going to the source can often provide illuminating answers. So, uh, this is a useful paragraph. This webpage provides weekly, preliminary estimates of the cumulative in-season numbers of flu illnesses, medical visits, hospitalizations, and deaths in the U.S. CDC does not know the exact number of people who have been sick and affected by influenza because influenza is not a reportable disease in most areas of the U.S. However, the CDC has estimated the burden of flu since 2010 using a mathematical model that's based on data collected through the U.S. influenza surveillance system, a network that covers about 8.5% of the U.S. population. So they're polling, essentially. It's sampling. This is the same mathematical techniques that lets you know what, which way Idaho is going in a presidential election when you've got 3% reporting. This is the same mathematical technique that lets you know the presidential approval numbers when you ask 1,500 people. This is how we find out the unemployment rate. We sample. We can't ask everybody. We don't have all the data, so we sample. The way that they track the flu, if the flu isn't reportable in all areas, then the data is limited. What we measure is what we know. So we have this huge band of numbers, and we'll talk a little bit about this, but it is worth noting that as I make this video, 51,000 Americans have died confirmed of COVID-19. So we're edging up in just under 2 months versus what was this is from October 1st to April 1st. So what's that? 6 months. So it's nothing to sneeze at. No pun intended. Um, and so you could read on through here. I'm not going to narrate to you. But there's really interesting things here. The main takeaway is that they consider the season done, and they don't have all the numbers. So if anyone's quoting really specific numbers, there is a range here, right? This is probably has to do with percentiles or confidence intervals. let's go back to the slides. All right, did that. Whoops, not what I meant to do. So let's take a look. We can calculate the case fatality rate, sort of a worst case scenario. There's a range of infections, 39 million to 56 million, and it's a range of deaths. So a worst case scenario case fatality rate would be 39 million cases, less cases, and 62,000 deaths, the most deaths. If you take that ratio, you get 0.0015 and so on. If you do the same thing for COVID-19, you get 0.05. That's 36 times greater than the flu case fatality rate. Now I know we've already done this before, but it bears repeating. These are both small numbers. They don't look very big. One is 0.1%, the other is 5%, 5.5%. But one small number is 36 times greater than the other. That might give us cause to take one more seriously. And, unlike the flu, generally speaking, nobody has immunity. Whoops. Looks like I've already finished talking about the flu. So, yeah, I suppose the takeaway here is that they're existing together. There's a limited number of hospital resources based upon what we expect each year. We know that COVID-19 is catchier, and we also know that COVID-19 is significantly more fatal. So I guess we'll pause here for practice.